Hello, 7th period. Today we're doing applications of surface area. For the most part, we're going to be doing surface area with cylinders, but number one is going to be a review of a box. So it says, Joy is wrapping a present. The measures of a box are 6.2 inches by 9.9 inches by 5.1 inches. About how much wrapping paper does Joy need? So we have our box. I'm just going to kind of draw a cube. Old school cube. Well, not cube, rectangle. And we'll say it's a 6.2 by 9.9, length times width times the height, which is 5.1. And we know that to find surface area, we have big P times H plus 2 times big B. Perimeter of the base, we're going to add up all the sides of the base. So we have 9.9 plus 6.2 plus 9.9 plus 6.2. So just so that y'all aren't lost, we have our base. Draw your base on the side like I taught you yesterday. And it's a 9.9 by 6.2, just so that y'all aren't confused on what's going on. That's our base. And when we add up all those sides, and y'all can pause if you need to, and put it inside of your calculator, we end up with a perimeter, which is 164.22. Everybody got that? And then the height of the figure is 5.1. And then our big B is area of the base. Since our base is a rectangle, we know that area is length times width. So multiply 9.9 times 6.2. And the area of our big B is going to be 61.38. So we found our perimeter of the base, our height, and our area of the base. And so now we're going to plug it all into the formula. And so when we plug it into the formula, I'm going to do that down here. I end up with S equals my perimeter, which is 164.22, times the height. So we're going to multiply it times the height, which is 5.1. And I'm going to run out of space, so I'm just going to go under there. Plus 2 times the area of the base, because remember we have 2 bases. And the area of our base was 61.38. And so put that all in your calculator. And you can pause if you need to. And so your answer ends up coming out to 286.98. And so that is how much wrapping paper we will need to cover up Joy's present. Here's all the work if you want to pause so that you can copy it down. All right, moving to number 2. A volunteer is making decorative labels to cover empty coffee cans for a charity drive. Each label will cover the entire lateral surface area. So that means we're going to be on our formula chart getting the lateral surface area of a can. What is the lateral surface area of the coffee can rounded to the nearest whole number? So we're doing that label that's around the coffee can that says the name of the coffee. That's why we're only doing lateral. So we know for lateral, if you look on your formula chart, it's 2 pi RH. When you look at the figure, it's the diameter. Remember we talked about that yesterday? The diameter is from one side of the circle to the other, and the diameter is 7. So if we want to get our radius, because we need an R for our problem, you're going to divide that by 2. So we divide 7 by 2, and our radius is going to be 3.5. That's what we're plugging into the formula. So then to find our surface area, we have 2 times pi times our radius, which is 3.5, times the height of the whole figure, which is 6.8. So you type that in your calculator, 2 times pi times the radius, which is 3.5, not the diameter, times 6.8. And then your total surface area is going to come out to, trying to check calculations. Okay, 149.4, but it says to round to the nearest whole number, so it's just going to be 149. Everybody got it? All right. Pause it if you need time to digest it or to ask questions. Here's number 3. In art class, a student is making a cylindrical lantern kite that is 30 inches long and 11 inches from one side of the kite to the other side. So here we see our kite. It says that the kite is 30 inches long. So that means our height is going to be 30. That whole kite is 30 inches long. Everybody got it? And then it says it's 11 inches from one side of the kite to the other. So basically that base right here of the kite, it's saying from one side to the other is 11 inches. What does one side to the other represent? Hopefully somebody says that represents the diameter is 11 on the kite. But we don't need the diameter for our formula. We need the radius. So we need to take half of 11. And we take half of 11, you get 5.5. So now we can plug that into our formula. Surface area, what does it want? What is the surface area of the exposed covering of the kite? Okay, so the surface area of the kite is going to be 2 times pi times our radius, which is 5.5, times 30, because that's our height. And so the lateral surface area of the kite is 1036.2. What is the surface area of the exposed covering of the kite? All right, so we have the lateral, then we have to remember on our formula, and I forgot to write it, the plus 2 times big B. So that was the lateral. So to find our area of the base, we're multiplying, not plus 2B, that's going to confuse you, 2 times pi times the radius squared. There we go. And so we have 2 pi times the radius squared. Our radius was 5.5, so we have 2 times pi times 5.5 squared. And when we add all of that up, we end up with 189.97. So we have our lateral surface area, 2 pi times RH. We have the 2 times pi times r squared, and we add both of those together, and your total answer ends up coming to 1,226.17. Everybody got that? All right, pause it if you need to go back to fully understand everything. We're skipping number 4 because I don't want to do one where we have to cut out the shading of the area. We're going to jump to number 5. Ruth wants to cover a cylindrical scratching post with carpet for her Persian cat. The post has a diameter of 8 inches and a height of 24 inches. About how many square inches of carpet are needed to cover the total surface area of the scratching post? So it said it was cylindrical, so it's like a y'all know I can't draw. I'm sure somebody's saying something shady. All right, so we have our can. The height is 24. Sorry, I'm driving, so we're riding. So we're scratching. And it says the diameter from one side to the other is 8 inches. Now we know we don't need the diameter, we're gonna need the radius, so I'm gonna do the parts over here. So we have our total surface area equation, which is 2 pi times r times h plus 2 pi r squared. And so when we find our radius, we cut it in half. Our radius is gonna end up being 4. The height of the figure is 24. And so now we're gonna plug all of that into the formula. So when we plug it in, we end up with 2 times pi times 4 times, I did something wrong. Hold on, let me pause. No, I didn't do anything wrong. I just need to calculate. We have 2 times pi times 4, which is our radius, times the height of the whole figure, which is 24, plus 2 times pi times our radius squared is going to be 4 times 4. When we do the first part, the lateral, 2 times pi times 4 times 24, we get 602.80, plus the 2 times pi times radius squared. That part is 100.48, or some of you might have typed it all in at one time, but you know I do parts. So then we add our lateral plus the 2 times the big B, and so the total surface area comes out to 703.28. Greg is collecting old toilet paper rolls for a science project. He must figure out the surface area of the roll. Remember, it has holes at both ends. If the toilet paper roll is 5 inches in height and has a diameter of 2 inches, what would the surface area of the toilet paper roll be? So I'm going to redraw a toilet paper roll. Looks like a cylinder. That one looks a little bit better. It tells us the height of the toilet paper roll is 5 inches. And then the diameter from one side to the other is 2 inches. We know we're going to need our radius, so we're going to cut that diameter in half, and half of 2 is going to give us 1. Everybody got it? And I'm going to go ahead and label my height, which is 5. And from there, I'm going to write the formula, because you need to write the formula. And our formula is going to be 2 times pi times our radius, which is 1, times our height, which is 5, plus 2 times pi times our radius squared, which is 1 squared. When we do the first part, which is our lateral, 2 times pi times 1 times 5, we get 31.4. Plus the back, which is 2 times pi times 1 squared, you get 6.28. And then you add both of those together, and the final answer is 37.68. And I need to put inches squared, because I'm sure Kennedy this whole time has been saying I did not write my units, which is inches squared. Sorry about that, Kennedy. Everything else up here is all squared. So that's the final one. Pause it if you need to rewind and look at it. Hope you have a great day.